In this video, we're going to take a look and see what impact using more rectangles will have on approximating areas under curves. So here we have f of x equals x cubed. On the x-axis, we're going on the interval from 1 to 4. So our x cubed graph looks kind of like this. We're going to go from 1 here up to 4. We're going to use right-hand endpoints. 1, 2, 3. So we have that as our first rectangle, our second rectangle right there, and the third one right here. The widths of those is going to be 4 minus 1 over 3, which is just 1. Good. And so our area is approximately 1 times f of 2 plus f of 3 plus f of 4, which if we did that, we would get 99 as an approximate area. We started with 2 because 2 is the right-hand value for the first rectangle that we have. What if we wanted to use, instead of 3 rectangles, what if we want to use 6? Well, our picture is going to look similar. Somewhere out here we have 1. Somewhere further out here we have 4 and 3 and 2. And then we're going to subdivide each one of these a little bit further. So we have 1 rectangle, 2 rectangles, 3 rectangles, 4 rectangles, 5 rectangles, and 6. So what is our area here? Well, delta x in this problem, we still have the same endpoints, b minus a, 4 minus 1, over 6. So the widths of our rectangles are now 1/2. And the area is approximately 1/2 plus f of 3/2 plus f of 2 plus f of 5/2 plus f of 3 plus f of 7/2 halves plus f of 4. And if we evaluate those and multiply, we will get something like 80.4375. So that is our second one. What if instead of using 6, what if we used 12 rectangles? Okay, here's 4. Somewhere over here we have 1. We have 2 and 3. We will subdivide each one of those, and then subdivide each one of those. So we're using again these right hand endpoints. Now we have 12 rectangles instead of 6. Each one of these goes a little bit over, but it looks like it's not going quite as much over as we were previously. Our area, well, let's look at the width. So delta x, same b, same a, so b minus a, 4 minus 1 over 12, which is 3/12 or 1/4. And so then our area is approximately the sum, I equals 1 to 12, of f of x sub I times 1/4, which, if we do that, we will get 71.859 if we go to 3 decimal places. Excellent. Given that the actual area is 63.75, which of those approximations is closest? The last one is closest, right? We can see that. How could you get a better approximation? Well, we could use more rectangles. And how could we get a better approximation? Use even more rectangles. How do we get a better approximation? Use more rectangles. So, from that, you might say, oh, so if I let the number of rectangles head towards infinity, then I should get really close to the actual area under the curve. And that's exactly what we'll see in our next video. We will see you there.